So, so we are going to go over I think, what is it, 2.5, the is permutation method, right? So that one was given two lists, A and B, return true or false based on whether they're permutations of one another. All right. So this one has a number of pitfalls in it, by the way. And unfortunately, unless you happen to know how to use hash maps, it happens to be actually quite a bit of a messy method. Although some people did come up with a nice hack, which people come up with that hack every semester, but it's always fun to see it. But let's just give an example of why this is messy. Right. A, B, and B, A are permutations of each other, right? These two guys are permutations of each other. They're the same items in the same order, okay? Sorry, they're same items just in different orders, but they've got the same counts, right? There's one B and two A's. Now, what makes it a particularly nasty method when you try to solve it by yourself is that oftentimes I see this as a failure case. AAB and BAB, right? So A has all the things that B has, and B has all the things that A has, but they have different counts of them, right? So they're not permutations of each other, so it should return false. So they have to have the same elements and the same counts, right? And as we learn, hash maps are actually the perfect data structure for this, but we don't know hash maps. So we just have to iterate through this using grid. Now, who solved this using comparables? Right, you did. All right, so can you briefly explain to the class what your solution was?
So the method extends comparable and then...
But I mean, like, in general, what was your idea, the overall?
Sort them.
Yeah.
And then equals.
Yeah, so she had the idea of just sorting that, oh, if two things are permutations, that means they have the same counts of things and the same items. So if I sort them, right, AAB, if I sort BAA, that's going to come out AAB. Compare them. If they're equal, they're permutations of each other. If they're not equal, they're not permutations. It's a very elegant solution to this method, with a caveat. You need to be able to sort the items, right? And you can't sort, and not everything is sortable, right? Can you sort a bunch of scanners? No, right? So as you'll learn in the upcoming videos for this week, there are lists of comparables, right? So the idea here for that solution is that you had E extends comparable E, which meant that basically all these E's here that you see, Java, I would like you to make sure that they are what we call comparables. And you'll learn more about them in videos. But essentially that means that they can be put in an order, right? That's what comparable means. They have an ordering, if you're coming from mathematics, right? They have an ordering, which meant that basically that we could easily do this method, collections dot sort, and then we could pass in A, and it would sort A, and then we could pass in collections.sort B, and it would sort B, and then you just simply compare the two to make sure, hey, are these two lists, equal? Do they have the same items? And that's a very, so this is actually, and I would actually count that as a correct solution, even though it completely changes the parameters of the problem, because that's also something you should think about in real life. When you have a problem that's super frustrating, if you can change the parameters so that it works for the vast majority of things so you get a working solution, do it. Right? If it works for the vast majority of things, then it's probably a good solution, right? Sometimes, as we'll learn, like with the traveling salesperson problem, there's just some problems that are too difficult, and so the best we can hope for is an approximation if you want to get a reasonable answer in a reasonable amount of time. A reasonable amount of time being, I'll still be alive for the answer. So, so that's one solution over there. Now, however, that wasn't, but let's say we want to check permutations of anything, all right? So that's what we're actually going to work on today for that. Now, to do that, we need to basically, we have to iterate through the lists, and see, hey, do we have the same counts of everything? Okay. So fortunately, we can start by making a couple assumptions. First off, the first step we want to use for this problem is we want to compare the two sizes of the list. If these two sizes are different, what can we conclude? If A and B are different sizes, what can we conclude? That it's false, right? They're not permutations of each other, right? If we've got AAB and AABA, right, they are not going to be permutations of each other, right? If there's just no way to swing that 3 is a permutation of 4, right? So that's our first step. Let's go ahead. So everybody go ahead and write an if statement, and then I'll come over here and I'll write it up myself. So go, and if you don't have a laptop, just pair up with somebody, right? So no worries. If you need to pair up with somebody, you can pair up with somebody. So write an if statement. Compare the sizes of the two lists. If they differ, return false. Yeah, probably. I mean, this shouldn't take too long. But I mean, I prefer to do. I found that basically doing in-class exercises, interspersed with the time, especially when it's on your own homework, right? All right. So everybody feel like they've got a handle on that one? All right, so that's fairly straightforward. If A dot size is not equal to B dot size, right, we can go ahead and return false. Now let's talk about just general strategies for working with these Boolean methods, like when you're trying to show is something have a property or not. The general strategy I found that works is that you should assume something, right? Assume what's easiest to disprove. So here, I'm going to assume that it is a permutation, okay? I'm going to assume that A and B are permutations of each other until proven otherwise, right? If I can immediately prove otherwise, right? If I can find a single condition that shows that they are not permutations for each other, I can immediately return false, right? I don't have to continue checking. But if I make it through all the checks, I'm going to return true. So I'm going to assume it is permutation. I'm going to assume it's true until I'm proven wrong. Okay, that makes sense to everybody? It's easier to prove that something's not a permutation than to show that it is, right? All right, so how do I do this then? Well, unfortunately, there's no easy way to go about it. What you have to do is that you have to iterate through all the elements in one of our lists, okay? And then for each item in that element, for each item in that list, let's say A, so for each item in A, what we have to do is that we have to then count how many times that appears in A and how many times that appears in B. Right? So that sounds a bit weird. We have to write a nested for loop that iterates over the same thing. That's a bit weird, but that's okay. So let's go ahead and write our outer loop for each item in A. We've got a for each loop, so why don't we try writing a for each loop? Because we don't care about the indices in this case. So to write a for each loop, remember, it's for E item in A. So for every item in A. That's all. That's all it needs to go through it. And now int. Now let's go ahead and make a int count A is equal to 0, int B, and an int count B is equal to 0. And this will be the number of times it occurs in A and the number of times it occurs in B. Okay? Now, what I need you to do which is the meat of this, is that I need you to now iterate over A and B and count the number of times item appears in A and the number of times item appears in B. Okay? So I'll leave that to you. I'll give you guys about 5 minutes to do that, and then you should be done with the method. It's a fairly straightforward method once you know how to do it. It's just a mess. When you're done, yes, when you're done with it, there's a Dropbox under quizzes that you can submit just that method to if you want, or you can submit the whole thing. It's just simply to check off that you did the work today, so you guys can get some free points.
If that's how we did it when we originally did it, can we just submit one we already have?
Yeah, sure. Mhm. And the main reason I wanted to I go over this one is because I from based on the past 3 semesters where I've given this problem out, I've seen it be a bit of a hurdle time and time again. Yep. Okay. So you want to count the number of times it appears in A and the number of times it appears in B. Now, if those counts differ, then you know that they're not. It's not that these two things can't be a permutation, right? If you count if you count one thing in A and 5 things in B, then they can't be permutations of each other because they have different counts of that particular item. All right. Okay. So let's go ahead and take a look at how to do that. So if you're using NetBeans or you're using, by the way, if you're using NetBeans or IntelliJ, you can just hit 4i and hit tab, and boom, it completes most of the for loop for you. 4i is equal to 0, I is less than a dot size. If a dot get I dot equals item, then we found the item, and so we do count A plus plus. And then we can just simply copy this and replace all the A's with B. Right? Replace this, count all, and replace count all the A's with B. Whoops. B, get item, replace with count B. Right? That makes sense. It's no different. So now, if count A is not equal to count B, well, then we've just disproven that it's a permutation, so return false. Let's go ahead and just make this a bit easier to get into one page. By the way, you can totally do this, where you have the if statement just condensed to one line, which is really only useful if you're like displaying it on and you need to fit everything into one line. So there's our completed method. All right, so notice that's a bit messy looking, right? In the sense that you've got this nested for loop that iterates over the same thing twice, which is kind of wasteful, right? But this is how you can tell if two things are permutations. And telling if two things are permutations, once you understand it, it's fairly straightforward. All right. So, let's see. That's been a productive 30 minutes. So I'm going to go ahead and take time for people to demo their stuff to me and to help people on that. And then I think maybe in like at like 1:30 we'll go over another quiz on writing on messing with array lists. Okay? So all right. Yes.
Is there any reason that you wouldn't or is there any issue with using a for each loop for the two nested?
Nope, no issues whatsoever. So the only issue there's ever in a for each loop that you have with a for each loop is that if you are trying to modify the thing you're going over, which is always a bad idea, right? It's always tricky when you do that as you're learning. And then the other thing is that when you care about what index something is, then you should not use the for each loop.
Thank you.
It's an excellent question.